everyone, my name is Muhammad Adlan Faris bin Nur AZIZAN. How are you today? I hope all of you are in good health because today we are going to learn an interesting topic, which is the application of Archimedes Principle in 15 minutes. Are you ready? Let's start our class now. Okay, our class today still in chapter pressure with subtopic Archimedes Principle. We are going to highlight two learning outcomes. So, at the end of this video, you will be able to relate the balance of the forces with the state of flotation of an object in a fluid, as well as communicate about the applications of Archimedes' principle in daily life. Before that, let us recall what we have learned before this. What is buoyant force? Buoyant force is the force acting upwards on an object immersed in a liquid when there is pressure difference between the lower surface and upper surface of an object. What is the formula will be used? The formula we will use is buoyant force is equal to weight of fluid displaced, or buoyant force is equal to rho Vg. Do you still remember rho Vg stand for what, right? Rho stand for density of liquid, V stand for volume of an object, while G stand for gravitational acceleration. Next, do you remember what is Archimedes' principle? Archimedes' principle states that an object which is partially or fully immersed in a fluid will experience a buoyant force equal to the weight of fluid displaced. Next, how do we get the formula? The formula for buoyant force can be derived as follows. Based on the diagram, you can see a cylinder fully submerged in a liquid. We need to relate with liquid pressure because right now we are involving liquid in this case. What is the formula for liquid pressure? The formula for liquid pressure is P equal to H rho G. Based on the diagram, there are two surfaces we need to focus, such as the top surface and another one is the bottom surface. Let's focus on the top surface first. We put the pressure on the top surface as P1 equal to H1 rho G. If you can see in the diagram, there is force exerted on the top of the surface, and we will put as F1 equal to P1A. We already have P1 in this case, so we can insert in the formula. Thus, the formula will be F1 equal to H1 rho GA. Alright, next, we move to the bottom surface. Pressure on the bottom surface will be P2 equal to H2 rho G. Meanwhile, the final force acting on the bottom surface will be F2 equal H2 rho GA. We already got equation for both forces acting on top and bottom surface. Now, we can get the resultant force where the resultant force is equal to buoyant force. The buoyant force will be equal to F2 minus F1. We insert the equation and try to simplify until we get the buoyant force is equal to rho AHG. In this case, the shape of the object is cylinder. Since the volume of cylinder is V equal to AH, we can insert it to be a buoyant force is equal to rho Vg. Are you okay right now? Hopefully all of you are okay because I want to get your fully attention right now. We want to learn the relationship between the equilibrium of forces and the states of flotation of an object in a fluid. When an object is submerged in a fluid, the object experiences two forces. The first one is the weight of the object due to gravity, and another one is the buoyant force due to the fluid displaced. The state of flotation of the object is determined by the relative magnitude of the two forces. There are three states of flotation of an object in a fluid that we need to know. The first state is the weight of the object is equal to buoyant force. In this state, the force is balanced because the resultant force is equal to zero. Thus, the object is stationary. Another state of flotation of an object in a fluid is the weight of an object is greater than the buoyant force. As you can see in the diagram, force is unbalanced because weight of the object is greater than the buoyant force. Thus, the object moves downwards with an acceleration. The last state of flotation of an object in a fluid is the weight of an object is lesser than the buoyant force. In this state, force is unbalanced because buoyant force is greater than the weight. Thus, the object moves outwards with an acceleration. You need to understand these three states because you can relate with the application of Archimedes Principle that we want to learn after this. Where do we apply Archimedes Principle? Let's start with a simple activity. Do you like to swim? Do you know why I ask you about swimming right now? Actually, Archimedes' principle also comes into play when you are swimming. You're able to float on the surface of the water because there is buoyant force acts on you while you are swimming. Do you realize about that? The reason why the swimmer able to float on the surface of the water as the pressure above the swimmer is greater than the pressure from beneath as the density of water is greater than that of the air. Do you ever try to swim in salt water and fresh water? Do you experience any difference? Actually, it is easier to swim in salt water than fresh water because the buoyant force not only depends on the water displaced but also on the density of the fluid. As salt water has a higher density than fresh water, the buoyant force acting on the body in salt water will also be higher as compared to fresh water, which is why it is easier for the swimmers to swim in the salt water. Physics is fun, right? Okay, now we are going to look at the bigger picture of the application of Archimedes' principle in our daily life. There are a lot of applications related to Archimedes' principle, but we want to highlight four only. For example, ships, submarines, hot air balloon, and hydrometer. Have you ever wondered that why large ships do not sink in the water? Well, the reason behind that is Archimedes' principle. Archimedes' principle is followed while constructing the ships. A large portion of the ships are kept hollow from inside that maintains their density less than the water density. The buoyant force of the magnitude equal to the displaced water exerts on the ship. The ship will float on the surface of the water. The second application that I want to introduce to you is submarines. Submarines also work on Archimedes Principle. Submarine can be submerged into the water and can also float on the surface of the water by maintaining the densities of the displaced water and submarine. These densities These densities are maintained by the two important components present in the submarine, that are the compressed tank and the ballast tank. If we fill the ballast tank with water, it results in a greater density of the submarine than the density of displaced water. Hence, the submarine dives into the water. Whereas, if this water is expelled out from the ballast tank with the help of the compressed tank, then the average density of the submarine becomes lesser than the density of the displaced water, and the submarine will float on the water surface. In order for you to get a clearer picture, let's watch this animation. The third application of Archimedes Principle is hot air balloon. Is there anyone right here have experience to ride a hot air balloon? Actually, hot air balloon use Archimedes Principle. The balloon rises in the air when the weight of the air surrounding the balloon is greater than its own weight. Whereas, if the weight of the balloon is greater, it will start descending. When the weight of the surrounding air and hot air balloon is equal, it becomes stationary. The density between the air and the balloon is controlled by varying the amount of hot air in the balloon. The last application is hydrometer. What is hydrometer actually? A hydrometer is an instrument that is used to measure the specific gravity or density of the liquids. It works on Archimedes' principle. It consists of a hollow glass tube with a bulb-shaped wider bottom, sealed from both ends. The wider bottom works as ballast tank, and it is usually filled with the lead, and the liquid whose density is being measured is poured in the narrow tube that has the graduation for the measurement. How it works actually? So, the hydrometer is placed in the sample liquid, and when it gets stabilized, readings are noted down. The level of hydrometer submerged in the liquid and the water displaced by it are measured to calculate the specific gravity of the liquid. If the hydrometer sinks deep in the sample liquid, it implies that the density of the liquid is less. The conclusion for this lesson are: how come there is no conclusion? Well, I think it will be better if you give the conclusion based on what you have watched in this video. Alright, so there are some questions that I have prepared for you to check your understanding. Number 1, state two types of forces experienced on an object when it is submerged in a fluid. Number 2, how does the submarine submerge and immerse in the sea? And the last question is how you can relate the sink of the Titanic with this topic. So, in the next class, I want to know your answer to this question. I also have included the attendant in this slide. Please scan this QR code and fill in your name with your student ID. With that, I end my presentation and thank you for watching. Have a nice day, everyone.